Hi, ladies and gentlemen, this is Mr. Green, and we're zooming through a system of equations, and so we're approaching the end of the semester real quickly. So I just want to give you a heads up. It's getting closer every time, so make certain you're understanding this stuff. Come to tutoring if you need some help, because some of this stuff is a little bit different than what you've done in the past, okay? So, last time we were doing linear combinations, and we reached an equation that we couldn't really solve. And so I wanted to pick up with that same equation and add one more thing to it, multiplication. We're going to use some multiplication to try to solve this one, okay? Now, I want to eliminate one of the variables. That's what we do when we're doing linear combinations. And I see that if I multiply one of them times -2, it'll get rid of the other variable. So let's try this. I'm going to take this equation right down here and I'm going to multiply it times -2. And I'll show you why. So on the first equation, I still have 2x plus y equals 60. If I multiply -2 times x, I get a -2x. I multiply -2 times 2y, I get a -4y. If I multiply -2 times 75, I get -150. Now, if I add straight down here 2x minus 2x, I get 0 right there. That's why I picked -2. How did I know to use -2? I looked at what it would take to get rid of one of these two variables. I was going to get rid of the x in this situation. And so now when I add the y's here, I get a -3y is equal to -90. I divide by the -3, and I wind up with y is equal to 30. I now know what y is. I can come back to this equation right here and say x plus 2 times 30. Now that's 60. X plus 60 is equal to 75. Subtract the 60 from both sides, and I wind up with x is equal to 15. I found my point, 15, 30. That's the intersection of these two equations. Okay? And we did the same linear combination, but I had to multiply one of them by a value to get rid of one of the variables. Let's see if it makes it a little clearer if I do one more. Here I've got a 2x and a minus 4x. Well, I see that if I multiplied this 2x times 2, then it's going to add to this 4x and it'll go away. So I'm going to multiply everything in here times 2. And what am I going to get? I'm going to get 4x minus 6y equals 0. And I have minus 4x plus 2y equals -8. And I add straight down, I get a 0 right here. And minus 6 plus 2 is a minus 4y equals -8. Divide by the -4, y is equal to 2. I figured out what y is equal to. So I can come back to one of these equations, minus 4x plus 2 times 2 equals -8. Well, 2 times 2 is 4, so minus 4x plus 4 equals -8. Subtract 4 from both sides, and I wind up getting -4x is equal to 4. Divide by -4 on both sides, and I wind up with x is equal to -1. My point where they intersect is -1, 2. Okay? Now this linear combination, deciding what to multiply them by, is not an exact science. Some people will say one thing, other people might say something completely different and do something completely different. And it just has to be whatever you think is the right way to go. Okay? And if you can get it so that you're eliminating one of the variables, remember, by adding these two together, I got rid of the x's here, and all I had was one variable with a number, and I could get a solution then. That's what we're looking for. That's the technique that you need to use. Why would we use this over substitution? Why would we use this over just the adding them together? Because Sometimes the equations are more complex and we can't just look at them and substitute one value into the other. Okay? Well, I wanted to make certain you understood these three methods for finding the solution of a system of equations. One is where the graphs intersect. Okay? Another one is by substitution. And this last one has been linear combinations. Well, let's see what's next in this unit next time.